Hi everyone. Yeah, for those who don't know me, I'm Alexandru Smochina. I'm software architect in Luxoft. And today, yeah, I was thinking what to present and what to share. And in the last 2.5 years, 3 years, we did a lot of things. And yeah, I think it's time to share from our experience. But before that, I would like to just give you a brief introduction of what we did. So our team did design, develop, and tested, even ported Adaptive AUTOSAR applications for a major German OEM. Actually, our software is now actually on the streets, and we're really proud of it. We work with multiple Adaptive AUTOSAR toolchains, and we are active in improving the way software is integrated and developed. What I mean by that is that now automotive is changing, and we're trying to see how can we improve the tooling and in general the ecosystem of tooling to help us instead of being against us, specifically when it comes to quality, software quality, processes, and so on. If we go at the higher scale, Luxoft is contributing to AUTOSAR, specifically to Adaptive AUTOSAR, since May 2017 in 3 ways: as a premium partner, as on behalf of other OEMs, but also contracted directly by the consortium. And what we are doing for the consortium, we are helping in defining specification, and we are involved in implementing parts of the Adaptive AUTOSAR demonstrator. Just to give you an overview of what is AUTOSAR. AUTOSAR is a worldwide development partnership of manufacturers, suppliers, and general companies, which are aiming towards bringing already known technologies to production. And this is actually an enabler for the developers, for users, providing the platform on which a real functionality should be integrated. So yeah, we don't have, let's say, moving parts, because you know, the ones that are developing on top of the AUTOSAR are the ones that are actually moving the if you have a mechanic or if you do something in your functionality. So the real functionality is usually on top of the platform. And to come to the agenda, what we want to discuss today is actually, I want to answer to one question from 3 points of view. Can I really write Adaptive AUTOSAR applications from 3 points of view, depending on your previous experiences? Obviously, the question is rhetorical. Of course, we can all write Adaptive AUTOSAR applications. Actually, our team comes from with a rather diverse background. I have, for example, Classic Autosar experience, more than 5 years. Some colleagues wrote Qt before. We have colleagues that wrote Linux kernel or maintain Linux kernel component. So it's a really diverse team. And what I want to show you is that actually coming from all these sides, you can actually participate in writing Adaptive AUTOSAR applications, because the complete technology is changing nowadays in terms of what features we have in the car, what features are needed in the car, and so on. In the end, we will share some lessons learned. Basically, what we learned in this 2.5 years since we actually developed Adaptive AUTOSAR applications. But before that, let's try to discuss about what is this Adaptive AUTOSAR and why do we need this. Of course, this is not a training of Adaptive AUTOSAR, but at least I can try to give you an idea and please explain you the use cases of why we need this platform and why not use something which is already there. There are several use cases which set the direction of this. First of all, new hardware appeared, which means that you might know before or existing cars which are now on the streets have even hundreds of components, electronic components. We call ECU those, and hardware is becoming more and more powerful, and there is now the tendency there to actually combine such smaller ECU into one. That's one of the factors. It's also because the way architecture is written, it's different. So there is a tendency to use more CPUs rather than microcontrollers. Another use case is that there is a concept called vehicle to X that appeared, and what this says that in the future we should be able to communicate. Your car should be able to communicate with not only with other vehicles but also with the infrastructure, with traffic lights, with lanes, with I don't know the sides of your I know highway, with traffic signs and so on. And this leads to you need to be able to introduce new features. You need to be able to connect with parts which are outside of your car. And maybe the third use case, which is now the big focus on, is highly automated driving. So what does this mean? This means you know, there are several levels of automatic driving, and to reach the highest level, so to have a fully automated car, we need to develop the right sensors and the right capabilities. And for that, you need, as I said, sensors, but you also need computational power, and the most important, maybe the connectivity at scale. What I mean with that, I mean that you need to be able to log the data so you can actually improve your algorithm. So when we are talking about petabytes of data, so that's an important, let's say, use case and driver for the platform. Actually, Wolfgang and Andreas described a little bit yesterday and the day before about these use cases, about driver monitoring, about connected mobility. Tomorrow, Kirill will and Valyatsin will speak about robotic drive, again connected with all these big changes that are coming to the automotive. And yeah, they are speaking about the actual functionality. I'm speaking about what's underneath this, the enabler, which will allow you to actually implement such functionalities. Going forward, some facts about Adaptive AUTOSAR. So as I said, you have all these use cases, but why not use some previous all technologies? The reason for this is that you need a system which is from safety criticality little bit less important, but also from the computing power less performant than an infotainment system. And that's why this platform sits somehow in between. And that's why actually the profiles of the developers are actually changing, because you can take developers from both sides, coming from infotainment or from Classic Autosar. Some buzzwords, you can see them there. The focus is on using Ethernet, using hardware accelerator, GPUs, FPGAs, using new technologies such as REST, service-oriented, and you use all that to improve to create a driving strategy based on the sensors you have, and to use also sensor fusion, to use multiple sensors to take a decision on where your car should go. So how does it look like now? Basically, you'll have one ECU, or anyway, reduced number of ECU, 3, 5, let's say 10s, which you have on which you have a CPU running, on which you might run bare metal adaptive AUTOSAR platform, or even a hypervisor on top of which you run several virtual machines. Some of them might be Adaptive AUTOSAR compliant, some of them might be just Android or even GenEV or the typical infotainment systems. Because in the end, Adaptive AUTOSAR does not aim to replace the existing platforms. It aims to fill the gap in between these two. And on the other hand, you also have a classic AUTOSAR because you need to connect to the rest of the car, and you have real-time and safety requirements for that. Also, the way software is developed is changing in the sense that compared to previous years, or you have now multiple companies delivering software for hardware which is developed by Tier 1, and even the OEMs are really more and more involved in software development. Let's look a little bit how the architecture looks like. So we can say that it's similar to Classic AUTOSAR, where you have a layered architecture. It's not that layered as the Classic AUTOSAR, but somehow they are trying to solve similar problems. You see, there is something called platform foundation. So this is the common functional cluster, which they should match somehow the functionality on Classic AUTOSAR, and then you have the platform services in which you have extra features. Yes, so one application will run on top of what we call AUTOSAR runtime of adaptive application. Two applications will communicate between them through what we call ARACOM or ARA-REST. I will go a little bit into details later on. If you want to persist data, you use ARA-PAIR, and at the lower side you'll have ARA-EXEC, which will be responsible for actually starting processes in your application. You have also something called platform health management. Of course, you want to make sure that your applications run correctly, and when this is not happening, you might want to be able to take action. Yeah. Going a little bit more. Now let's try to start answering this. Let's try to answer this question: can I write a adaptive AUTOSAR application? Coming, for example, from Classic AUTOSAR. There is a table. I guess it's the same as it has been shown in probably every presentation you have seen about adaptive AUTOSAR. Yeah, these are the differences between them. Of course, Classic AUTOSAR is based on C, ANSI, and it runs on top of the operating system is OSEC. For adaptive AUTOSAR, we have to use C++14 and an operating system that is compliant with POSIX. The communication paradigm is totally different. One is signal-based and one is service-oriented. We'll go again into details about this later on. And I think what's more important is that in Classic AUTOSAR, you will execute most of the times you'll execute your code in place. This means you don't have your binary, let's say, loaded at runtime or stopped at runtime, because you only have a binary which includes already statically linked all the applications, all the components actually, because in Classic AUTOSAR they're called software components. Yeah, in what is also important in Adaptive AUTOSAR, besides specification, there is also something called code or demonstrator, AUTOSAR demonstrator, in which the consortium tries to actually validate the specification. So there is now let's say a sample implementation for it's called demonstrator, yeah, in which the specification are tested. What's familiar if you're coming for Classic AUTOSAR? Well, the static configuration. In Classic AUTOSAR, pretty much everything is statically configured. In Adaptive AUTOSAR, even though applications are started independently, they start based on some configuration, which is most of the time static. I'm talking here about persistency configuration, service definition. So which services are used? It's always statically defined. Execution management, platform health management. Basically, pretty much every configuration it's static, so it's not changing during the runtime. Also, what is also common, the RxML is the formal used in both methodologies to keep formal description of your system. Of course, this doesn't mean that if you have a Classic Autosar XML, now you know how to edit an Adaptive AUTOSAR XML. They use different schemas, obviously, but at least it's a little bit familiar. I have included a table which tries to match, let's say, a Classic Autosar components to Adaptive AUTOSAR components. The mapping is not one-to-one, obviously, but just to give you an idea, when you see ARA pair, you might consider that you might think of NVM from Classic Autosar. When I'm talking about communication, ARA-COM and ARA-REST, I'm referring basically we're trying to solve the same problem in Classic Autosar they solved using RTE and COM-stack. For diagnostics, it's a little bit simpler actually from functionality perspective. You have only one component which is offering both the functionality of DCM and DEM, only differently configured. But since you work, maybe if you work with UDS before, this will be really familiar to understand what's going on in there. Related to the services, UCEM, basic software, and maybe OS should be also here. The equivalent will be a combination of execution manager, state manager, and platform health management. Of course, this is a really oversimplified version. There is no mapping one-to-one, so we have to go really deeply into details to understand. Now, to show you how the methodology looks like. Today, we're actually discussing, this is the methodology presented by Adaptive AUTOSAR. Today, we are discussing about this small block here. It sounds complicated, but oh yeah, don't just bear with me. It's actually not that complicated, and I will try to simplify it for you, or even oversimplify it for you. So in short, as a developer, what you need to be able to start, you need a model, an XML model, what this XML model will contain. So by the way, if you don't know an RxML, it's what the name says, AUTOSAR XML. It's an XML-based configuration of your system. But before having that, the OEMs and the tier ones will start prior to you actually, before you start the implementation of the application, they will start thinking of the system description, meaning how many ECUs you want, the topology of your system. They will discuss about what services you want on this system, how do you split them, which ECU will provide which service, and so on. And also they will consider the machine design, meaning what kind of hardware architecture I need. Do I need special hardware, GPU, FPGA, and so on? And once you get all this done, you'll get a machine description and service interfaces, which you will be using when you're creating your detailed your design of your application. Detailed design from system point of view, architecture from application point of view. So at this level, you will have to think of several topics like persistency, how do you handle requests, the application lifecycle, which I will also handle. And once you have this in mind, you of course will start implementing, and then you'll get two things. You'll get the binary and manifest, which I have to go back, manifest, which are JSON files, and these two things will be integrated later on in the hardware, where you can actually play around, do tests, and even release at the end if everything is correct. I showed here at the on the right side the package to be used for OTA. This means it's quite a good idea to have the way to do software updates right at the beginning of the project, because yeah, the sooner you do that, the easier it is to get rid of some problems. What is different? Well, the communication paradigm is totally different, and I will go also into details. So as opposed to signal-based communication, here you have a service-based communication, and yeah, there is also a completely different way of deploying and debugging. In Classic Autosar, you might have been used to have real hardware on your desk, and you need an emulator, another device to debug your system. Here, things are a little bit easier, I would say. You can use virtualization, and you can also use even a Raspberry Pi. So like I do have here, I have a, for our projects, we use a Raspberry Pi. It's more than enough for what we need. Of course, you have to brush up your C++. 14, so modern C++, deprecated features from previous versions are not allowed. From the tooling perspective, there are more and more open source tools used. I will go into details when we reach to the Linux perspective. And that's what I said, hardware emulation is still used. Now, let's say we know web technologies. How is this from our point of view, from the web developers perspective? Well, what's familiar? Well, the idea of service-oriented communication should be familiar. Looking at this picture, you will have, maybe I can also use some laser pointer. You'll have this application. Let's assume this is your application, and you want to access the different servers. Most of the times you'll need an endpoint, and this endpoint is most of the time configured in a API gateway, which will give you the actual forward the request to the actual server, which will provide your answer for your request. And in a similar way, Aracom manages to intermediate this communication between two applications, one offering service and one consuming one service. Besides Aracom, in Adaptive AUTOSAR, you have also support for REST. So there is a part of a functional cluster called REST, and we will also go a little bit into that details. From the developer's perspective, developing Adaptive AUTOSAR application seems to be closer to how backend applications are developed in web, not that close to how front-end applications are developed. And of course, you might, if you developed web applications before or web technologies, a lot of virtualization is used. You have something running somewhere in the cloud, or you have even containers locally in your target, and so on. A little bit of Aracom. Aracom, it's the preferred way of doing communication between two components in Adaptive AUTOSAR. It's, as I said, it's service oriented. What does this mean? This means that before an actual communication, two applications will have to, one to register the offering part, to register to a service registry, and the other one to discover the service and find it in the service registry. And once this connection is done, you can actually do a call. From an implementation perspective, it uses a proxy skeleton architecture. You see here, the skeleton is the one that provides the service, and the proxy is the one that consumes. A service is composed of three things: events, fields, and methods. Methods is probably pretty obvious. It's more like a remote procedure call. Fields and events are kind of the same, with the difference that the fields allows you the possibility to buffer, and when you use fields, you are forced by the standard to initialize this field with a value, while with events it's not the case. It's like fire, and then the other application will be notified. You get this with fields also, but yeah. Concerning RRest, unlike Aracom, it does not come with a complete out-of-the-box API, which will allow you directly to construct RESTful services. It's more like a framework. So what you see here as an object graph, it's something which you have to come up with. Of course, from your application, you can access directly RRest, but without the, if you don't have the need to abstract this to let's say a domain level, to construct a data model which you want to access later on with HTTP methods like get, post, put, and delete. If you don't need that, you can directly use RRS otherwise. But most of the times, I would assume you will need this. Of course, there is support for getting notifications once I don't know, a resource was updated, you'll be notified. This is only scratching the surface. It's much more complicated, but for such a presentation, there's not enough time to go into details. What is different? Well, the process of developing software is stricter. If you did not work in automotive before, yeah, you find out now that there is something called ASPICE, Automotive SPICE, where whenever you develop software, you have to be able to first prove what is affected by every change, and also you should be able to reconstruct your system later in time at a request. The methodology, of course, also different. The service definition is a little bit different. You are not that flexible. It's not that like you discuss with the guys from a different team. Oh, guys, I have idea about this new service. Let's agree on the resources we want to exchange, and then we're done. This process is usually handled by the OEM, and it's statically defined. There is an entire approval chain which has to be passed before actually introducing a service into the car. So it's not that like you'll implement your service and you will somehow deploy it to an ECU, and now you will be able to access any service. It's this one, it's not working. Now, typically now, normal, let's say web service, it's most of the time stateless, which means you can use this into your advantage to scale up or scale down your application, meaning using multiple instances of the same service, and rely on the fact that you'll always reply, which this thing is, at least what we did not see, it's not applicable, at least for now in Adaptive AUTOSAR. At least our application, for example, it has a state. Right? It's not that easy to do that. There are some limitations. For example, each process in Adaptive AUTOSAR can access one database, one persistency, but that persistency can only be accessed by that process and not by multiple processes. So you need at some point to put a proxy in between if you want to share that with different applications. It's possible, but not easy. Of course, you have to, again, brush up your C++, most probably because C++ might not be the #1 choice when it comes to developing web applications. Yeah, and now we are at the, let's say, I would say the sweet spot. Yes, I'm coming from I have a Linux background, let's say, and I want to start adaptive application, writing adaptive application. What's in for me? Well, yes, that's I would say the sweet spot you are in, because you should be already familiar with working with a POSIX system. Many of the debugging tools are now open source and again familiar. For Git probably it's used now everywhere. I don't think it's only strictly related to Linux, but tools like Yocto and Buildroot, which are used to completely build your entire Linux distribution, are used for building C++. We use CMake. Actually, all the tool chains we use so far, all the Adaptive AUTOSAR tool chains actually use CMake. In some projects, we also have seen Conan for managing dependencies. And here for debugging, you use normal Linux tools, just to name a few: strace, Valgrind, and GDB. And as I just mentioned before, for actually deploying, you will use QEMU for different architectures, or even a real hardware. Of course, as I said before, we use Raspberry Pi quite often in our day-to-day development. One important thing, maybe if you're coming from Geneva, also what's again familiar to you, this idea of Frank ideal, which is, let's say, an equivalent of RxML, in which you can describe your system, starting from software interfaces to I don't know, data types and so on. So at least you will be familiar that there is something there like this. Now, going a little bit into more details of what you'll get after you receive these RxMLs, you will use a generator from which you will get two things. You'll get some C++ files and headers, and you will get some JSON files, which are the manifests. And you use that to implement your functionality, right, using an IDE of your choice, because it looks like it's not really now the IDE, which I would say is enforced by someone. Since it's Linux, people have different preferences. You use the compiler in your project. Might be we use the GCC, we use CLang, so depending on your project, and you get a binary and a manifest. You deploy those to a real hardware or a QML, and then of course you run your applications and close the loop. If you have issues, you go back to the implementation and so on. So pretty similar with what you are used before. What's different? Well, not much actually. You have to take care of the life cycle of your application, which means interaction with the rest of the platform. And you have to get familiar with service-oriented communication if you are not already. But again, these are not rocket science topics. It's quite easy to grasp these topics. So now let's speak a little bit about the life cycle of your application, which is pretty simple actually. Your application will be started, which will cause it going from init state. Actually, we'll start us in init state. You will finish as an application. In your application, you'll finish the initialization, and then we'll switch to running state, and then at request of the execution manager, you will go to shutdown. What does this mean? Typically, the OS will start execution manager and state manager, and also platform health management, depending on how it's configured. And then state manager will start your application. It might be that in some use cases your application will be stopped and others will be started and so on. They are what we call run levels or functional cluster. You start different functional clusters. Why do you need this? Because I don't know. For example, you have I don't know, parking system algorithm which is normally active while you're parking, and you have, for example, cruise control functionality, which might want to be stopped when you are parking, but you might want it to be on when you are going on a highway, for example. And then this means these two applications will be started and stopped depending on in which state is your system. And state manager is aware of your system. Therefore, we'll ask the execution manager to start your application. And then once your application is it's initialized, we'll report back that I am running. And then it will do its magic. I mean, whatever your application will have to do. Basically, what our colleagues spoke about yesterday and the day before, and what they will speak about tomorrow. And during this cycle, there is also the possibility to configure your platform health management to, let's say, act like a watchdog for you. So there are several types of doing that, several ways. You can send a keep alive cyclically. You can have some sort of deadline monitoring. This means you send a checkpoint and then you actually tell platform health management, if I'm not sending another checkpoint in this amount of time, please restart me or have some behavior. And you also have some logical checkpoints in which if you reach some checkpoints in a different order, then you are supposed to, you again can take some action. Yes, state manager and platform health management can ask the execution manager to terminate your app. This actually happens by sending a signal to your application, and your application will be able to handle this and deinitialize all the things and then send to terminating. There is also a timeout. If you're not terminating, you will be anyway killed at some point. Yes, so the last point is what we actually learned in these 2 years. We often had a situation in which we had to port our application from one stack vendor implementation to another implementation. And because the standard is actually evolving, it's actually the first ready to use in cars version was 1903, if I'm not wrong. The differences in data types and APIs were quite large. So that's why we call this actually porting from one toolchain to another. And we even had a situation in which we had to let's say, update our application to be compatible with a newer version of the same toolchain, which again was pretty, the changes were not always backward compatible. So we lost a lot of time in this. So we learned that it's actually better to isolate your core functionality from the exterior using an adapter and ports architecture, in which you'll create basically some adapters for your from the platform. You might say, oh, but that defeats the purpose of the platform of the Adaptive AUTOSAR. But at least until the standard is fully stable, I think that's a good approach. What we noticed also that because we are working under Linux, but most of us were working actually on virtual machines. Whenever we have to emulate ARM QEMU, it's quite slow. So what we did was actually to exchange the kernel of our QEMU with a Raspberry Pi kernel, and we just, as I showed you, we run everything in a Raspberry Pi because for speed reasons. Yeah, one recommendation is also to use continuous integrations or ways to measure your non-functional requirement, meaning how much RAM you consume, how much ROM you consume, and so on. Because having a new platform, actually, you are clueless when it comes to estimating it. You don't know how your application will actually behave. I mean, you can guess, especially if you're coming from Linux side, but yeah, so that's why it's actually okay to start monitoring as early as possible. And last but not least, do not disconsider diagnostics, which means the ability of configurer software using what we call now UDS, or the ability to report diagnostic error codes from the beginning, because this will help you in the end with debugging. You'll be able to figure out what are the issues with your software. Yeah. And with this, actually, I close my presentation, and yeah, it's question time. So if you have questions, feel free to ask them. I'm not sure if Julia, you can
I'm here.
unblock
I'm here.
also
Yeah.
people if they have questions.
Actually, there are none of them in the Q&A yet. So maybe somebody's typing something right now. So let's wait. Maybe somebody is trying, to formulate a question in the mind. So let's give people a minute or a couple of minutes.
Yeah. There is actually. They are from Dennis there, but they are on the other.
Yeah, it's in the chat. So
yes.
yeah.
So things like dynamic memory, since things like dynamic memory allocation in STL are allowed in Adaptive AUTOSAR, also Linux could be used as operating system. Yes, actually Linux is, I mean, it's POSIX based, right? So it is used as operating system. but you have also other options, because sometimes you need to have, let's say, more strict requirements from timing perspective, and you have, I don't know, things like FICO-OS, QNX, and so on. So yeah, I hope this answers your question. How the application allocated at runtime on Adaptive AUTOSAR? Well, in most of the cases, it's actually no big difference. But there were some ideas in consortium to, let's say, allocate some time slots in which you are allowed to allocate memory or deallocate memory. But in our project, we are not using it. So we are just using the simple C++ resource acquisition initialization system. Let me, in slide 11, the connections between services. What are these connections, lines or they ports? Let me switch back actually. 11, I guess. Maybe not, not the right slide. Can you be more specific, please?
Yeah, there are a lot of slides with connection lines, really.
Is there an issue regarding running time critical applications along with AUTOSAR application? So in general, what I have seen, not in the same environment, in the sense that you will not run them on top of POSIX, but you run them, whatever is critical, you run them in a Classic Autosar. It can be on the same SoC. So for example, I know Renesas has let's say a controller or a CPU which has a real-time core. But in general, if you have real-time requirements, you will run them in an isolated environment, not in the same place. Is AUTOSAR open source platform? Is it available for partners only? As far as I know, it's so the specification is open. You can look it up. It's autosar.org. Actually, most of the information you see here, it's taken from autosar.org. Even the sources, I pasted sources from where I took the pictures, if they are not created by me. Yes, the specification is open, but as far as I know, you have to pay as a partner if you want to use it in your real project. Service oriented. Okay. Now I got it. Ruben, let me go back here. You mean in this slide? Yeah. These are actually in the line. So in the slide, first time is service oriented communication. What are the lines? These lines are actually connections, basically, not ports. I'm not showing, let's say, components here. It's just the data flow. How do you protect your application? Do you have a special protection method for this application? Yes, that's a good question. Basically, you will have in a service-oriented diagnosis, as a service provider, by design, you will not know who is actually using your service, right? So there are some ways of authentication before actually starting using a service. In the projects we used, there are some manifests which are checked before requesting a service. I don't know actually the complete details, but I can actually point you to the cluster which is taking care of this identity and access management. You can look into the specification of this. Another, is there any specific distribution that is recommended for AUTOSAR? No, we have used so far. Because we did not integrate in the project we are working on, we are not integrating the operating system. This comes from the supplier, and in some cases this is built using Yocto, and it's a specific flavor of the of Linux distribution. In some other cases, they use Buildroot. but there is no, let's say, specific name to point to. Yeah. And of course, if you have more real-time requirements, you might look towards some distributions which are offering this. Yeah. Other questions?
I believe we answered all of them, and I can see nothing in the chat.
Okay. We still have like 10 minutes, so let's wait a couple of minutes. Maybe there are some questions, and then yeah.
Yeah. So I will use this time to announce our next talk tomorrow. We'll be talking about a very niche thing and very unusual thing for Luxoft, which is a robotic drive platform. And we will even have 3 speakers talking about covering like different parts of the platform. So I expect some deep dive information tomorrow, just as we had today, actually. Yeah, I can see one more question in the chat. Do we need to do special Linux kernel configurations? Hope I pronounced it right.
Yeah, I guess it's quite open. If you need it for your specific target, of course you need, because obviously you'll have specific peripherals on your target, right? From service perspective, I mean, let me go back to the architecture. So the standard does not, let's say, standardize the implementation of these functional clusters. So if, for example, one platform provider decides to implement, I don't know, Aracom in a specific way, which needs a specific kernel configuration, then obviously that's a dependency, and they have to state it. And because there are some cases in which the Linux is not provided by the stack provider. But yes, in these cases, you might need to do special kernel configuration. Is there any simulator build in this platform? I mean, if I'm okay, I decide to investigate this platform. Have I any way work? Yes, you can. Basically, we use QEMU. QEMU is widely used. That's the thing I like, actually, since I started working on Adaptive AUTOSAR, that I only need my laptop to work. I am not really tied to hardware. I can always, and you can even compile it for x86, and you can run it on your Ubuntu, for example. This is the case for the demonstrator, for Adaptive AUTOSAR demonstrator. You can out of the box build it for your preferred distribution, and then run it natively. The demonstrator, it's actually accessible by the partners, so it's open. You can ask in your company if your company is actually a member of the consortium. So yeah, this is possible. Okay. Then I guess we are faster than we are supposed to.
Yeah, but I believe it's okay.
Yeah. Okay. Anyway, I'll send you the slides. So, and I will send you along with my name. If you have any questions, just feel free to send them to me. I'll try to do my best to answer. I have not touched all the functional clusters. In fact, I only touched a few of them. But yeah, I'll do my best. What is the main communication backbone in the network? Ethernet. Yes, Ethernet is it's actually, that's the one of the drivers. It has to be Ethernet. Yeah. Even with the Classic Autosar, the communication is over Ethernet using some IP. So you can probably mark this also.
Is the champion with questions today.
Yes.
Really.
We should give him a prize.
We have none. I'm sorry.
We gave answers. Yeah.
Yeah, just our appreciation for asking really good questions. Yeah, it means that the presentation was really interesting and helpful and useful for you. Yeah, thank you too.
Yeah.
So
I,
guys, yeah.
yeah. Just as an ending, there are some documents in the AUTOSAR consortium which are actually have this name EXP from explanation in their name. Those are the ones, if you want to start looking into Adaptive AUTOSAR, maybe those are the ones you should start with. They are described in more human readable form because the rest of the documents are usually pure specification. And if you have read before a standard, it's a rather formal language without describing why things are chosen like this. It's just they just describe what the specification says. So it's a good starting point to start with this explanation documents. There is a filter actually on AUTOSAR.org to look into this. Yeah, so just give it a try. See. Yes,
Yeah, it
thank
should
you.
be useful. Yeah, thank you, Alex, for the very detailed and I would say deep dive presentation about the AUTOSAR Adaptive. Yeah, as just Alex said, guys, I will send you PDF files together with the recording version of all webinars next week, just as we upload it to YouTube. So you will be able to review all these materials and find answers to your questions maybe when you watch it one more time. And I wish you very good end of the day or morning, depends on when you are now, and hope to see you tomorrow talking about robotic drive platform.
Yeah,
Thank you
thank you.
and have a good
Thank you,
one.
Julia.
Yeah, bye bye.